All right, homework number 3. Let's do the homework first. Everybody sent me the files, right? With the homework. Okay, good. On average, commuters in Phoenix, Arizona require 40 minutes to get to work because of traffic conditions, weather, things that change every day, right? It doesn't take you exactly the same amount of time every day. So there is a distribution, right? So average time among all people who drive to work is 40 minutes. Assume that all commuters, for all commuters, the times to get to work are normally distributed with standard deviation of 10 minutes. Joe is an average Phoenix resident, and he gets to work every day. What is the probability that on any given day, Joe will require over 45 minutes to get to work? Okay, so first, let's draw the picture, right? So all times that are people take to get to work are normally distributed. So we'll have distribution like this, right? So this is distribution of times. I'm going to write letter T. The average is mean 40 minutes, right? And the standard deviation, sigma, is 10. Okay, so the first question asks you what's the likelihood that it will take him longer than 45 minutes, right? So over here we have time equals to 45, and all times that are longer than 45 minutes are located to the right from 45, right? So what are we looking for is this area right here. Okay, so this is the probability that time to get to work will exceed 45 minutes. All right. So let's go ahead and set up the SPSS. Because SPSS can compute only cumulative probabilities, that means to the left, right, from a number, then probability that time will take longer than 45 minutes, we're going to compute as 1 minus probability that time is going to be shorter than 45 minutes, right? So we need to find time less than 45 minutes, probability of that. Okay, so there you go. I'm going to have to define variables, right, in my SPSS data window. So I switch to the variable view, and for the distribution, I define mean, standard deviation, and the value of time, well, I'm going to call it time, okay, and the probability. All of them are numerical, of course, right? Now, for the probability, I'm going to actually increase the accuracy. By default, it's 2 decimals. I'm going to increase that to 5, so that it shows me more accuracy. And measure, I'm going to set scale for each one of them, right? Scale, scale, scale. So now I switch to data view. The mean is 40. The standard deviation is 10. Time is 45, right? And in this cell, I'm going to ask SPSS to compute me the probability that time is shorter than 45, right? And then I'll find the other one. Okay, so I go to the menu transform, compute variables. My target variable that I'm computing is probability, right? Probability. And that should be equal to the CDF, right? Cumulative density function, okay? Everything from minus infinity on the left up to 45 minutes. And I need to pick the CDF function for normal distribution. There it is. So the first thing that it asks for me is the quantity. That is my time, right? 45 minutes. Okay. The next thing that I have to bring over is mean. That would be 40, and then standard deviation, the last one. So I click OK. It says change existing variable because it wants to overwrite the variable that I have already labeled, right, in my data window. So I click OK, and there is the answer for me, right, 0.69146. All right, so now I switch back to the notes. So it's going to be 1 minus 0.69146, okay? And whatever the answer is, it's probably 30% or something like that, right? So I'm going to point 30854 or something like that, okay? All right, so this is the answer to first question, right? Okay, good. All right, let's take a look at, let me put this window on the background. The second one, what is the probability that Joe will take exactly, no more, no less, but precisely 40 minutes to get to work on any given day? We don't even need to compute that one, right? What's the answer? 0, right? Because there are infinitely many different possibilities, right? How much time it's going to take him. On some days, he's going to just breeze through, right? So it's going to take him like 15 minutes, and that's it. On some days, the traffic is going to be so badly congested that it will take him over an hour. Not a lot, but every once in a while that will happen. So infinitely many different possibilities. So many that possibility of each one specific value is just 0, negligibly small, right? So this one is 0. Okay, let's take a look at problem part C. Joe just left home from lunch to attend a meeting with Chief Executive Officer that will happen in just 30 minutes. If the boss routinely fires employees who are tardy for a meeting, what is the probability that Joe will still be employed tomorrow? So, will still be employed means that he makes it under 30 minutes, right? So he has 30 minutes before the meeting begins. For him to stay employed, he has to spend 30 minutes or less getting to work, right? So essentially what I'm looking for here is probability of less than 30 minutes, right? So I'm going to change time to 30 and recompute the probability, right? I don't even have to change anything right now in terms of setup. So I just go to compute variable and it's there already, right? CDF computes the probability, so click OK. All right. And there it is. So the chance that he will still be employed is 0.15866. Approximately 16% chance, right? That he will still have a job. Not a lot, right? Most likely he will not make it on time and angry boss will fire him. So he needs probably to start making his resume, right? To find a new job. Okay? Make sense? All right. The last one was a little tricky, right? Joe is so punctual that he leaves home for work at exactly same time. His work starts at 8 a.m. sharp. Due to the traffic jams during morning rush hours, Joe historically was tardy for work on 38.5% of days. What time does Joe leave home for work every morning? Briefly explain the train of thoughts. How did you arrive to that answer? Okay, so let's go back to the drawing board, right? Okay, so I'm going to erase some of that stuff here. Whoops, not all of it. Okay, all right, and time equals to 45. So he leaves himself exactly same time to get to work, right? If every day he leaves at precisely same time, that means that between that time and 8 o'clock, he gives himself certain amount every day, right? And the problem says that he was tardy. Tardy means late, right? Late on about 38.2% of all the days, right? So that means that time to get to work took him longer than what he allocated or shorter than what he allocated? Longer, right? He was late, so therefore it took him longer, okay? So longer means greater than that time, right? So that means I'm looking at the area in the right tail or in the left tail? Right tail, agree? I'm looking at the area in the right tail. So this is the time t equals question mark that I want to find, right? That's how much he gives himself. But 38.6% of the times it took him longer, right? So that means that this area, okay, is 0.382, correct? All right. Now, for the inverse function in Excel, we can compute only the area to the left, correct? The cumulative function computes only the area to the left. That means that I can specify this area for Excel, right? So if in the right tail I have 0.382, how much do I have in the left tail? 1 minus that, right? So 1 minus 0.382 gives you 0.618. Is that correct? Yeah, something like that. Okay. So now let's switch back to this one. Okay. And this time around, I'm looking for the value of time given the probability, right? So I'm going to erase time, and the probability in the left tail is going to be 0.618, right? If I remember correctly, 0.618 in the left tail. Okay, so on 61.8%, he makes it under that time, right? So he's not late, but 31.2%, it takes longer. So I have to go back to the transform, compute variables, right? Now, this time around, I'm not calculating probability, but I'm calculating time. So my target variable, I need to put down time, and it's different function, right? For calculating the values given the probability, I'm using inverse function, okay? So here, in the list of function groups, I find inverse density functions, and I need to pick up the one for normal distribution. Double click, and it takes 3 values, right? Value number 1 is the probability. That's the one right here. The value number 2 is the mean for the normal distribution, and the value number 3 is the standard deviation, okay? And when I click OK button, it says I'm going to recompute the variable. Yeah, do that. All right, 43. I get 43 minutes, right? So every day he gives himself 43 minutes to get to work, right? So that means that he leaves 43 minutes before 8 a.m. If you subtract 43 minutes from 8 a.m., you will get how much? 7:17, right? 7:17 in the a.m. That's when he leaves, right? By the way, what if he leaves exactly 40 minutes before 8? Just kind of for the kicks. The average time to get to work, 40 minutes, right? So how about this? I know that my average time is 40 minutes, for example, right? So I'm going to say, okay, I'm going to leave, the work starts at 8 a.m. I'm going to leave 40 minutes before the work, so that means 7:20, right? On what percentage of days, if that happens, I'm going to be late? If I give myself exactly the average time to get to work, 40 minutes, on what percentage of days I'm going to be late? 50%, right? Half and half, right? Because from the distribution, this is how much I'm giving me, right? So half of the time I'm going to be less than 40 minutes on the road, and half of the time I'm going to be more than 40 minutes, right? So therefore he leaves a little bit earlier, right? He leaves, he gives himself not 40 but 43 minutes, right? And still 38.2% of all the days he is late, okay? Make sense? Uh-huh.
I have a question. Why, like, if you type in 0.382 in the probability, why don't you get the same number for time? Because aren't you finding, like, the point instead of, like, the probability? So shouldn't it be, like, a point that separates both sides?
If you type 0.38, what you're finding is left tail, right? If you type 0.38, 0.382, what you're finding is this area, correct?
Yeah. Oh, okay.
So therefore, what that means is he's going to be on time actually, 0.382%, right? Because it will take him shorter than that, 0.382% of the time, right? Yeah, the problem is other way around, right? He is late, 0.382%. Late means you need to look at in the right tail, correct?
Thank you.
Yeah. Make sense? All right.